All right, so where we left off, had written a search algorithm, a search method, where we passed in an array, we passed in a target value, and then it searched it and it either returned a -1 to indicate that it hadn't found it, or it returned the index of it. So, write a helper method called findStudent that searches for an ID value within an array of student IDs. FindStudent should receive an ID parameter, that's our target, and return the index if not found -1. Oh, and you're not going to give us the code for that. Be that way. Maybe it's in the book. I should go see if I can find the code examples that are referred to and upload them. So sorting an array. I mean, we could go back and look as a quick reminder of what we did last time. Well, hopefully it's in our mind. That's not it, is it? Definitely not it. What was our last lecture? Where are we? Was it I?
This should be J.
All right, so this style of code here, where you start at the beginning, you go through the end, you increment, you compare, and you do something, whatever something is. Very, very, very common programming paradigm. A search algorithm can be written in different ways. It could even be written as a recursive routine that continually called itself until it found it. We are certainly not going to do that, although we may hit recursion just for a day. That's the idea. Step through it. If we find a match, return our match. Else, just increase our counter and keep going through it. How about reversing an array? Excuse me, sorting an array. Well, thankfully, sorting an array is incredibly easy since we have methods for doing so. What if you had to sort it by hand? If you had an array by hand, it looks something like this. And say we had the value, a Jack, Sam, Bob, Ted, and Fred. Here's one sort algorithm. It's about the simplest. There are two that are considered the simplest, I believe. The selection sort and the bubble sort. What the selection sort does is it scrolls through the entire thing, finding the one that needs to go into position 1. So it checks, okay, position 1, what's the lowest? Well, the first one is Jack. Is Sam less than Jack? No. So our lowest variable still equals Jack. Is Bob less than Jack? Yeah, sure is. Is Ted less than Bob? Nope. Is Fred less than Bob? Nope. So Bob is our current lowest, so we would swap those. And now we're done with that first position, so we start with the second one. Now the lowest, and I mean by alphabetical, right, is Sam at position 1. We check, is Jack less than Sam? Yeah, it sure is. So now our lowest is position 2. Is Ted less than Jack? Nope. Skip it. Is Fred less than Jack? It sure is. So at index value of 4, 0, 1, 2, 3, 4, and now we swap elements 1 and 4, right? So that becomes Fred, Fred, and this becomes Sam. And actually, at this point, we are done. I could keep going, but you get the idea. I just happened to arrange the data in such a way that after 2 swaps, we're done, right? So we search the entire array, keeping track of the index of the lowest value. When we find it, we swap it with that one. And then we skip to the next one, and we do the same thing. Find the lowest index and we swap them. And we keep doing that until we've, come here and we know that this one's in the right place, which would guarantee that that one's in the right place as well. That's called a selection sort. 5, 10, -3, 20, -2. What is it doing? That's not the lowest. Oh, it found the lowest and it swapped the lowest with the first. Then it ignored everything else and it found the next lowest and swapped it with the second. So 2 wound up there. Then it searched the rest of it. Well, 5 was already the lowest, so it didn't need to do anything. Scratch that. Go to the 4th one. Find the lowest and swap them. And then it's done. That's a very, very easy sort to write. It's not the most efficient by far. There are some recursive sort algorithms and other algorithms that are far more efficient. But that's a selection sort. So sorting an array. You could include a sorting method in every class that needs sorting functionality. We might need a student sort method, a book sort method, a product sort method. Or suppose you want to make a generic sorting method that receives an array as a parameter and then sorts it. Yeah, sure, we could do that. We could write something that receives an array of ints and sorts it and returns it, or something that receives an array of strings and sorts them and returns them. So to make the sorting method generic, you can put it in a utility class and put several of them. You can overload it so that one sort algorithm operates on ints, and another one operates on strings, and another one operates on doubles or something like that. Why would it be easy for other classes to use the sort method if the sort method is implemented as a class method? So we're on J, I believe. Get rid of my project declaration. All right. So say we wanted a utility class to have a sort method in it. So class utility, and I'm not going to actually write the sort method, but public static sort. And what would it take? It would take an array of ints. Like that. And it would do something really cool with it. And I forgot to put the word void here. Right. Do something really cool with the array. Since I made it static, I can use that down here real easily, right? I can declare my array of ints. I'm not taking much time in creating my array because I didn't create much time in writing my sort algorithm, right? And then I could call sort, utility.sort and pass that array in. What if this had not been declared as static? What if I wrote another method called reverse that would reverse the method, but I forgot to make it static? So public void, notice I'm leaving the word static off, reverse, that takes an int array, and again it does something cool with it, right? I should actually just print out a word, right? But anyways, this is just an example. Now I can't use it that easily. I can't do utility.reverse IA. Why? That was so handy to be able to do that. I can't do it because this is not a class method. It's not a static method, meaning that I'm actually going to have to create an object of type utility to be able to do it. Okay, fine, I will do that. Utility util equals new utility, parentheses in parentheses, semicolon, and now I can call it. Right. So it works. Why did I have to create an object? There was no reason to create an object. This class has no data in it, right? There's no instance data. So there was no reason for us to have to create an object. The only reason is because we forgot to put the word static there. If we add the word static there, then all of a sudden we could change it back to the way it was. That's just going back to the prior topic about class methods versus instance methods. Instance methods, you have to create an instance of the class. An instance method is one that is not declared as static. Okay, now I believe that the arrays class already has a sort method built into it. Right? Just like that. Boom, it's already done. And it's probably done a lot more efficiently than we would do it ourselves if we tried to code it as a selection sort. And I'm not going to make you memorize the selection sort algorithm or implement it. If this is a data structures class, I might, but it's not. When the Java API gives you something, you may as well use it. So let's print the sort array now that we have sorted it. So system.out.println parentheses quote IA equals end quote plus. And how do we turn the array into a string as fast as possible? Arrays dot to string parentheses IA. Right. That's just for debug purposes. The user would not want to see it in this format most likely, but it sure does make it easy for us to see. It's just like printing a list in Python. We get to see a nice little list there. And in fact, it is sorted. Did I start off sorted? Did I put 1, 4, 6? Oh, it sure did. So did that prove much? No. How about we make it more data, right? 8, 6, 7, 5, 3, 0, 9, right? And I guess she lives at area code 646. Jenny. Let's run it. All right, and there we go. It has been sorted. How about a reversing of it? If we wanted to reverse it so that the high number was here and the low number was here, it sure would be nice if Python gave us a reverse method. Arrays.reverse. And I believe that they don't. But we could write one. We could write one pretty easily. Maybe we'll implement it there. And heck, maybe we'll even make it static so that we don't have to create the object. So how would you sort an array? Excuse me. How would you reverse the array? You just swap the first and the last. And then you swap the second one. You swap the third one. You swap the fourth one. You swap the fifth one. And so on. How many times do you need to swap? The length divided by 2. Right, because by the time you've swapped the middle 2, you're all done. So the length of this is 9. 9 divided by 2, rounded down would be 4. So after we sorted that one, swap those 2, swap those 2, swap those 2, swap those 2, we should be good to go. Well, how do you pick the index of which one you're going to swap? Well, if the length of it is 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Is the length of it really 10? Okay, yeah, so the length of it is 10. Let me add some notes here. If the length is 10 and we have a counter going, we want to swap 0 with element 9. Is that not right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we want to swap 1 and 8, and 2 and 7, and 3 and 6, and 4 and 5, right? And that's enough. So the length divided by 2 is enough for us to iterate through this. And the length minus 1 minus I is enough to calculate that number. Or in other words, the index value of the highest one, which is 9. So we ought to be able to do that. Now if you're going to swap two variables, you need a temporary variable, right? Because you just can't say IA subscript 0 is equal to 9. Well, you've erased it, right? How can you copy it back? So we need a temp variable to hold those. This ought to be a short thing to write. I hope it is, because it's not important enough to spend like 20 minutes on. So we need to know the highest array value, the highest index value. So int high equals array dot length semicolon, oops, minus 1, right? Because the length of the highest element, highest index, the highest subscript is n minus 1, where n is the length. and we need a temp variable. Then we need a for loop that's going to count from 0 to high minus 2. High divided by 2, excuse me. Or length divided by 2. I think they'll both work, but I'm going to go with length minus 2. So for int I equals 0. No, I'm going to go with my intuition. I is equal to 0. I is less than high divided by 2 because we only have to go through half the array. Semicolon I plus plus. And we need a block of code so that we can do our swaps. Temp is equal to array subscript 0. Array subscript 0. Not 0 though, it's I, isn't it? So temp is equal to array subscript I. Array subscript I is equal to array subscript high minus I. And then array subscript high minus I in subscript equals the temp. I think that'll do it. We just need to go and add another print statement, maybe copy and paste our print statement to prove that it works. You know, what would happen if this was actually just high rather than high divided by 2? It would just go all the way through the array, swapping to the very end, but we didn't need to do that because by the time we've gone halfway through it, everything has been swapped. So this is end of reverse. This is the end of the class. And down here, we printed out the array. Okay, now we should see it be reversed. Let's find out. And it is. It's reversed. Hope that makes sense. Basically, for one thing, I want you to have the idea of how to swap two values. And the other is I want you to have the idea of stepping through an array. Again, we have in a counter, which goes from 0 to some value inside the array. Strings work the same way, except strings are immutable in this language. In some languages, if you have a string like this, and don't type it because I'm probably just going to delete it, if you have string name is equal to Bob, and you feel like changing the first letter, you could do name dot or name subscript 0 equals R, either that or even with single quotes around it. It's just not going to work because once a string has been allocated, you can't get a hold of. You can access the individual elements with .char@, but you can't change them. Immutable means non-changing. Well, what if you absolutely had to change it? Well, that's a darn good question. I don't recall. Name dot set. Nope. Name dot compare to equals get bytes index of last index of replace. Replace sounds good. Replace the old character with the new character? No, but I want to replace by position. Starts with, ends with, substring, to uppercase. Well, what do you know? It's a very elementary string operation and is not leaping out with me. Replace a char in a string in Java. Java string replace method example. But I don't want to replace all O's with P's. I want to replace by value, by position. So I'm not going to spend much more time on this. I keep saying that. But it's important to know. Replace a character at a specific index in a string. Method 1, use the string class. Sounds great. How do you do it? Original string, substring. Oh, look at that. They're building a brand new string. Saying, starting at the index, change the index, and then that character, and then change the rest of them. Well, that's cheating. Otherwise, use a string builder class. A string builder is not an immutable object. once you use a string builder class and you set it equal to your original string, then you can do things like set char at. That would not be a bad thing for us to learn. I'm going to tuck that away in my head as something that we ought to cover in the string builder class. All right, back to arrays. Get rid of name and name.bob. The selection sort implemented a two-dimensional array. It's just an array with both width and depth, right? Columns and rows. In Python, two-dimensional arrays look kind of strange. I don't even bother teaching two-dimensional arrays in Pythons, but in most languages, they're pretty easy. You just address the elements by their index values, by their row number and their column numbers. This is row 0, column 0, which is an 8. This is row 0, column 1, which is a -2. And this is row 0, column 2, which is a 4. So, as with two-dimensional arrays, there's two ways to assign values in it, right? We've seen the use of an initializer list to create a one-dimensional array. We can do the same thing with a two-dimensional array, but check this out. Check out what we're actually creating. If I paste this in a notepad, and I space it out a little bit like this, now you see what it is, right? It's an array of arrays, right? Because we've seen this. We've seen doing int xx equals, right, 1 comma whatever. This is an initializer with a set of ints. Well, this is an initializer with a set of arrays inside it. And since it's a set of arrays, since it's an array of arrays, we need to use two subscript indicators to allocate it. Or you just allocate it as an empty array with a new command, and then you start poking data into it, right, by their positions. Filling them up with random numbers and things like that. We could do that. But for now, let's go ahead and create an array just like we saw. And how about an array of names? Colors. String, that makes a two-dimensional array. Colors. Why am I making a two-dimensional array of colors? I can't come up with a good reason for why I'm doing this, but we will demonstrate something. So string, two subscripts in a row, two empty square braces, colors equals, and then the first line, the first row of it, let's stick some names in here, like red, end quote, comma, green, end quote, comma, quote, blue, end quote, end of brace. And now, in order to add the second element, the second row, after our curly brace, we need a comma, and we can do the same thing again. Black, end quote, semicolon, or not semicolon, end quote, comma, gray. When do you use the E in gray, and when do you use the A? End quote, comma, white, end quote, end curly brace, and that curly brace marks the end of that little subarray. So that marks the end of that row. And one more, just for giggles. Gold, end quote, comma, silver, end quote, comma, copper, end quote, close brace. Now you see I allocated it that way, making it real obvious what it is, but I could delete all the character terms, right? And it would work just as well. So now I'm going to change the value of this gray to gray spelled with an E, because honestly I don't remember which one's the preferred. Maybe we'll call it something else. Slate. I don't know. Gray with an E. Anyways, colors, subscript, and what row is it in? Well, if that's row 0, it's in row 1. What column is it in? Well, if that's column 0, that's column 1. Equals gray. End quote. Now that's awesome and stuff, but we need a way to print it out. You print out well, not only print out, just about everything you do with two-dimensional arrays, you do with nested for loops. Use single for loops to process a normal array. You need a nested for loop to process one of these. Why? Because a single for loop would only let you process each one of these like that, right? You'd get the entire row. But instead, the outer loop is going to give us the row so that the inner loop will let us access the individual columns inside that row. So I like the variables R and C for row and column, or maybe ROW and COL. So for parentheses, int ROW equals 0, semicolon. ROW is less than, okay, how do we know how many rows there are in it? Good question. For now, I'm going to hard code it to 3, which is real lame, because what if we added a 4th row? The PowerPoint will tell us how to do it, and it's different in every language. That's why I've forgotten. Okay, that's our outer loop. Now let's do our inner loop. For parentheses, int COL equals 0, semicolon. COL is less than 3, semicolon. And again, that actually should be the number of columns in that row. And then COL plus plus. Then we can print it out, and I'm not going to use print line. I'm just going to use print because I'd like for every element in that row to all be together. I don't want to hit enter until I reach the end of the row. So let's use printf. System.out.printf, parentheses, quote, what's our maximum space we need here? It looks like it might be 6. Why don't we make it 8 just for good sake? So percent 8s. And I'm not going to put backslash in there for the reason I already mentioned. All right. And then we need to print out that element. Just like we did here, we're going to use the array name followed by the subscripts, which is going to be subscript row and subscript column. So colors, subscript row in subscript call in subscript in parentheses semicolon. Then once we are done printing out every column in that row, it's finally time to go to the next line. It's finally time to hit the enter key on our printing. So we're just going to issue an empty println, system.out.println, parentheses in parentheses. If I've done it correctly, that should print out our array of colors just like how we entered it. You know, red, green, and blue on one line and so on. And it did, right? Red, green, blue, black, gray, white, gold, silver, copper. Not sure how much more I want to say about two-dimensional arrays. You can talk a lot about them. Like what if you wanted to summarize, what if you wanted to add the total of each element in this array? Now these elements are strings, so we're not going to be able to do that. But if they were numbers, and you wanted to get the row total, then you'd probably stick, I'm probably going to delete all these, so I wouldn't necessarily do this. I'd create a variable, row total equals 0, right? And then inside here, I would keep adding on to the row. Total plus equals, you know, that element, whatever element it is, row, column. And then down here, I could print out the sum. Now, since I wasn't smart enough to think in advance and actually make these numbers, that's not going to work, right? Now, why not finish it off, right? So we could print the total before we printed the next line, if we had a total to deal with. What if you wanted to add the whole thing together, right? Well, this is the row total variable, so that we could summarize everything in that row. But if you wanted to add up every number, then you'd need a variable up here, you know, that was a sum of everything, right? And then you could add the row totals to the sum if you wanted to. Sum plus equals row total. That makes sense? This little loop ought to look real familiar. It's how you always get the sum of an array. You declare your variable as 0, and then you just add to it inside the loop. And then to get the sum of the whole ding-dang thing, you create a variable above the nested for loop, and then you add the total to it there. Or we could just do it right here if we wanted to, right? Sum plus equals the element at row call. What if you wanted to get the totals of the columns? You would just reverse the terms. You'd make it for int call equals 0, call less than 3, call plus plus, and row, right? So that you'd be accessing the entire first column, then you'd be accessing this entire second column, then you'd be accessing the entire third column. Okay, so like I said, I was laying by hard coding 3 into this. Let's go find out how to do it the right way. Cities.length, that indicates probably the length of that row. How about the length of the column? Nope. Well, at first you don't succeed. You Google it up. Yeah, okay, that's real lame. They don't show you how to do that. Thankfully, Google is our friend. Print 2D array Java. 20,000 examples. We need our outer loop to be the length of the array itself. When we call array.length on the two-dimensional array, this is the number of rows. And then when we're ready to do the inner loop that steps through all the columns, you ask for the length of that particular row. Okay, that's not too hard. That's going to require very few changes to our code, like 2 lines worth. So instead of 3, the first 3 we're going to replace with colors.length. That's how many rows there are. I could add a comment somewhere to that effect. For a 2D array, array.length is the number of columns, number of rows, and array subscript x in subscript.length is the number of columns in that row. So I changed this first 3 to be colors.length, and this next one is going to be colors subscript row in subscript.length. Oh, well, it still worked. We didn't actually materially change it, right? Because we had hard-coded 3. The row lengths are still 3. The only way to prove that it would work would be to go and add a 4th row of colors. That wouldn't take long. I'm just going to copy that second row, paste it. Well, what in the world? There. Alrighty. That looks really odd. I don't know what happened when I copied and pasted. Let's try that again. And just add 3 more colors. Pink, orange. Somebody else tell me another color. Aqua. Now it should work. Why? Because colors.length is 4. And colors subscript 0 is 3. Now, wouldn't it be crazy if we added accidentally 4 colors, like mauve, to one row? That's called a jagged array or a ragged array. It's an array when you have rows. Some rows have more columns than the other. And in a way, that's kind of crazy talk, right? But it works. It's just a weird idea. So you can have jagged arrays where each row has a different number of columns. My brain doesn't think that way, but you can, because each one is just an array. One of them could be totally empty, right? I could make another array here that didn't have anything in it. And a so-called empty array, and it's not going to break our code. It printed out blank because it was a row with no data. Now that's really looking ugly, so I'm going to remove my empty line from the array, and I'm going to get rid of mauve, so I have a nice, clean, tidy, regular, rectangular array. Some people call arrays matrices, matrix. You probably had to suffer through matrix algebra at one point where you multiply two arrays by each other. My brain totally does not remember that anymore, how to do anything like that, and I don't even think I'm going to ask you to do it in an assignment. Notice that there's a comment here. Let's see what it's suggesting. And I'm going to, for every array in the colors array, and then for every string in that array. Well, that's pretty cool. It's using for each loops now. It's saying for every array inside the 2D array, and then for every string that's in that array. Print it out. That's cool, and the syntax is actually easier. What's the disadvantage of using a for each loop? The only disadvantage in using a for each loop is if you need to change the elements. Like what if we were going to go through an array and multiply all the elements by another number, right? And we wanted to change the array. You can't do this because when you do this, it's effectively read-only. If you try to make any changes to it, it doesn't really change the array. And as a matter of fact, I'm not even sure it will let you make a change to it, or whether it'll flag it as a syntax error. I guess there's we could find out real fast. I'll just try to do that. Well, it's not an error, but I guarantee that after this is done, the array is untouched. Even though we changed it, this value is a copy of that particular element. It is not that element, so making a change to it doesn't touch the original array. That's a problem if you want to change the values of the array. That's when you don't use for each. All right, since we talked about calculating the sum of an array, right? Let's actually do it. Let's make an array of numbers. But this time, let's not initialize it with an initializer list. Let's just make it a certain size. So array subscript subscript nums equals new int. And what do we want it to be? A 5 by 6 array. So int subscript 5 in subscript 6 in subscript. And then we could store some pieces of data in there. Not sure what. Let's put some pieces of data in it. Like let's say nums subscript 0 in subscript 0 in subscript 0 subscript 0 is equal to 3. And what have I done wrong? Create class. That would be
I don't think you're in main.
I'm sorry, I haven't spotted it.
I don't think you're in the main.
That would be why I'm not in main. Thank you. That's why I usually do that. End of main. Thank you so much. I was getting quite outright. All right, there we go. And let's make nums subscript 1 1 equal to 4, and nums 2 2 equals 5. Let's skip row 3 and do nums 4 4 equals 6. All right. So now we have a grid. Oh, I meant to undo these changes. I guess I'll leave them because I've typed past it right when it offered to change it to for each loops. So this one, I was going to do this one to for each, but instead I'm just going to do it old school. So for parentheses, int row equals 0, semicolon, row less than the number of rows in this array, which is nums.length, semicolon, row plus plus, and then for parentheses, int call equals 0, semicolon. Call is less than the length, the number of columns in this array, so in this line, excuse me, so num subscript row in subscript dot length, semicolon, call plus plus. Now let's print it out with another printf. So system.out.printf, parentheses, quote. I don't know how much space we ought to allocate per value, really, since they're only 1 digit long, and let's give them 3. End quote, comma, and then the value itself, which is what? Nums subscript. And what am I going to put inside my subscripts there? What will complete my code? What do I want there? Well, what's my iterator variable called? What's my loop variable? The first one, the outer one. Come on, guys. What's my outer loop variable? Well, this is my outer loop, so what's the variable? Yeah. And so what's the inner loop variable? Call. Yep. And after we're done printing out every column in that row, we're going to print a blank line. So system.out.println, parentheses in parentheses. Now what are you griping about? Malformed format string, unknown format. Okay, why did I put %3 there when it needs to have a letter indicating what type it is? If %s is string and %f is for float, what's an integer? D. Yep, D. There we go. Thank you, NetBeans, for saving me from myself there. All right, now when I run it, there's my little grid with my numbers being set. 3, 4, and 5, and 6. How's about we use a for loop to fill up some of the rows? Nah. Let's not say we did, but let's go ahead and calculate the sum of each row and then the sum of the entire array. So we need a variable here for the sum of the entire array, and I've already created one called sum, although it was a comment, so I can probably get away with doing it. Yeah. So int sum underscore array equals 0, and then inside here we need, inside the outer loop, a row total, int sum underscore row equals 0, semicolon. And then while we're printing it out, we may as well add these numbers up, right? So sum underscore row plus equals nums subscript row subscript call. And let's add that to our total sum as well. Sum underscore array plus equals nums row in subscript call in subscript. I forgot to print them out, but at least it ran without error. Okay, so where am I going to print my total? Before I go to the next line, right? I've printed out all the columns, and then I want my total to appear here. So here, why don't we just do quote space total equals end quote plus sum underscore row. Or I could use a printf or whatever, right? And where am I going to print the total? the sum of the entire array at the very bottom, outside both loops. So system.out.println parentheses quote array total equals end quote plus sum of the array, sum underscore array. And there we go. I'll bring the code back, but the sum of the first is 3, the sum of the second is 4, the sum of the third is 5, the sum of the fourth is 0, and the sum of the fifth is 6. And the array total is that, and I trust that that's correct. 3 plus 4 is 7, plus 5 is 12, plus 6 is 18. Okay. So what if we'd been a little bit more clever and not called those 5 and 6, but had declared a couple of constants? Final int num underscore rows equals 5 semicolon. Final, or we don't even need to make them final. Why? They're not supposed to change, but whatever. And then int num underscore calls equals 6 semicolon. And then replace the 5 with num rows and the 6 with num calls. Now, to test it out, just to be idiotic, I'm going to say that there's 50 rows. Yeah, all right. It's excessive. What if I made these too small? Then I'm going to get an exception trying to access them, because if you write past the int or read or write, if you access an element that's outside of the proper subscripts, in other words, past the length, the end of it, it blows up. Yep, and it sure did. So 5 by 6. Back to that. So an array of objects. This is so important that I'm about willing to postpone talking about this until the next lecture. We could do 10 lectures on this if we wanted to. I'm in a hurry to get to array lists, though, so I don't think we're going to do 10 lectures on this. Probably one's going to be enough, and then we get to array lists. But we do need a nice, tidy homework assignment over this idea. So what I want you to do is write a program that asks the user for the number of rows, asks the user for the number of columns, and then calculate a number of values as the number of rows times columns, and then generate that many random pairs of numbers where x, or the row, is equal to a number between 0 and rows minus 1, and y is equal to a number between 0 and calls minus 1. Adding the word between here, right? Stop that. And then fill the value. Wait, I forgot to tell you to allocate the array. Allocate the array of the specified size of ints. Make an array of ints. Fill the array at position x y with a random number between 0 and rows times columns. So if you have 10 rows and 10 columns, then the number should be between 0 and 100. And how many of them are you going to generate? You're going to generate 100 numbers. So if we were to work our way through this, the user tells me that they want 6 rows. They want 6 rows by 6 columns. So the number of values we want to add will be 6 times 6, right? And then we're going to loop. So loop, comma, generating that many random pairs. And when I say that many, I mean value, or number of values. Number of values, random pairs. So we're going to generate 36 random numbers. The first one, x will be between 0 and 6. Well, 0 and 5. The second one will be between 0 and 6. So let's say that it picked that 2 was x value and y was the 4th value, and then it would set that array at those specific values at 2, 4 equal to yet another random number between 0 and 36. That makes sense? And it's just going to keep looping. I'm going to delete all this stuff because this is kind of confusing. Maybe I'll provide some pseudocode, but I hope that this would be enough of an explanation. You're just going to use a loop that's going to count from 0 up to the number of values, or 1 less than the number of values. You're going to generate random pairs of x, y values, and then at that position you're going to set it to a random number. Then you better print it out, right? Print out the array displaying row sums and the array sum using a nested loop. Are we comfortable with that? Okay with that? Maybe we need to hit the idea again on Tuesday, just a little bit, but are we okay with that? Hope so. If not, let me know by Tuesday, right, so that I could extend the deadline a little bit. And we talk about it a little bit more. And I'll write this up as a nice, pretty assignment. What's the other thing that we could have done? I could have asked you to fill in every single value with a random number, right? Then you just use a nested loop, and instead of printing it out at that spot, you just assign a random number to it. If you totally can't figure out this bit, right, you'd at least get partial credit for doing that, right? Just running through and inserting a random number in every row column position. But this is more fun, where you make pairs of numbers and then you set them to another value. When I say it's fun, I don't know if you agree. All right, let's stop.